We actually took less than 2 years from contract award until to go design, build, and go fly both the GA and Anduril aircraft. That's like less than half of the benchmark for any unmanned platform before that. Speed to field capability is so important. CCA is really emblematic of what the Secretary was talking about. And that's why when I talk about the government reference architectures, which make it so easy to bring new software capability to bear, or building physically in a modular way so that I can bring new physical capability to bear. I can make those mods, bring that capability much quicker. And so I was very excited to get picked up. The 11 months, you'll never forget going to test pilot schools. No lethal decisions are made without a human in the loop making that decision. The most agile thing that the Air Force has and has always had is the ingenuity of our airmen.
We're far away from getting a lot of the similar kind of benefits that Tesla, a great example, has with their autonomous driving capabilities.
We're really close to going flying.
Hey, Tim, thanks a bunch for joining us here on Micro Journeys. It's a pleasure to be out here in Ohio and to sit down with you and chat a little bit about your story. So thanks for joining us here.
Yeah, thanks for having me. I'm kind of excited.
Yeah, so it's let's start with a little bit about how you got involved with the Air Force. Was this a childhood passion, or was this something that you just kind of fall back into?
Yeah, so interesting story. I come from a family that does not have a lot of military in history. My grandfather did serve in the Korean War in the Navy, but really beyond that, not much military service. And so when I grew up in Indianapolis and decided to go to Purdue University, and so I was at Purdue. I was a freshman before I really had thoughts of joining the military. I had a really good friend, one of my best friends, who was actually an Army ROTC. And Army didn't really interest me all that much because I was a huge fan of aircraft all growing up, but not necessarily on the military side. Then I found out, I met with some of the recruiters and ROTC there at Purdue, and they told me about opportunities to go fly, opportunities to get school paid for, and to get to experience something that like I didn't really have any experience with at all. And I don't know if you know this, but ROTC, like the first 2 years, you can kind of do it without any commitment in general, unless you signed up for a scholarship. But you can do it for the first couple of years, and there's no commitment. And so they're like, just come in and give it a try. And I just love the people. I love the service aspect of it. And obviously I love airplanes. And so signed up, took a scholarship, and continued on for the rest of my years at Purdue. And then, signed up that was definitely going to do 4 years. And that was, I don't know, like 24 years ago or so. It's just been such a good ride. So really been pleasantly surprised at every different turn that the Air Force has had for me. To get to experience it.
So when you go from Purdue into ROTC and you decide to, join the Air Force, you start out with, I believe it's Test Pilot School is one of the early stage pieces, correct?
First thing I went and did when I got commissioned is actually the colonel who was in charge of the ROTC detachment, as a senior, and he said, "Hey, how do you like skiing?" And I was like, "Water or snow?" And he's like, "Snow skiing." And I was like, "I haven't done it much, but sounds fun." He's like, because you're going to Hill Air Force Base. So as I started off as an aeronautical engineer in the Air Force and working on the A-10, actually, which is still around, still phenomenal platform. We are retiring it, but has done great things during its years of service. But I got to work on that. Even at that point, by the way, it was called a mature and proven aircraft, even back in 2002. So but I worked on that for a little bit, and then the Air Force sent me to go get a master's degree, actually, at Air Force Institute of Technology here at Wright-Patt. And out of that school, I got picked up to go to Test Pilot School, which was one of my major goals I wanted to do in the Air Force. And so I was very excited to get picked up. And I had my orders in hand to go to Test Pilot School, which the Air Force Test Pilot School is out at Edwards Air Force Base, kind of in the Mojave Desert. So I had my orders in hand. my wife was not super excited about moving out to the desert of California. But then I got a call from the commandant, and he said, "Hey Tim, I've got a deal for you." They wanted to send me to the Naval Test Pilot School, which is at Pax River, Maryland.
Oh,
So
interesting.
complete different coast, different service. Of course, that sounds amazing, and it truly was. Got to go. I was learning everything about being an airman, like airmanship, and I was learning it with a different service, which was really interesting. And the cool thing about it is they sent me to go do what they call the rotary wing course. So think of helicopter course.
Okay.
Because they had planned for me to go, which I did, go work on the CV-22 right out of test pilot school. And so I got to learn all about helicopters, as well as, fixed wing aircraft, fighter aircraft, as well as understanding our large, tankers, the ISR aircraft, all that kind of stuff, learning how they differed, how we test them, and how we can contribute to fielding capability. So that was it's 11 months that, you'll never forget going to test pilot school.
So you got to see the integrated air battlefield, it sounds like, while you're there. I mean, everything from the tankers to the sensors, like you said, to the fixed wings, to the rotary. I mean, you got to experience all of this over at Pax River. And it sounds like that's kind of a foundational piece. Is that a unique thing for you as your career, or is that the way that people get their exposure over at Navy Test Pilot School?
Yeah, so everybody's journey is a little bit different. The Air Force typically sends a couple people to the Naval Test Pilot School a year, whereas the Air Force class is around 2024. So we send 24 people through the Air Force Test Pilot School every class. So, and they do them twice a year. We only send about 2 to the Naval Test Pilot School. So there's not a lot of other people that I in the Air Force that I interact with that did go to Naval Test Pilot School. So it's unique kind of in that respect. It's the Navy school is run a little differently than the Air Force's. And so got to do an experience, like you said, that was foundational in my career, and very different than some of my peers got to do. So I'm pretty fortunate to go do that.
After you complete this portion of your career, there's really kind of 2 different directions you could go, right? And you decided to go down the path of the programs and the program offices. Why don't you describe kind of what led to that decision and where you landed right after you were done with Navy Test Pilot School?
Yeah, thanks. It's a good question, which I spent a lot of time actually mentoring younger officers that are kind of at that crossroads as well. And so I get the question a lot. And so because it's important to them. For me, the way it worked out was I went to Naval Test Pilot School. After that, I had orders to go down to Hurlburt Field, which is right near Eglin in the Panhandle of Florida, working on mainly CV-22. So the Osprey, the tilt rotor. Worked on that, as well as some other special operations airplanes, different C-130 variants. And so I did that for several years, and actually worked for General Schaefer. He was my ops group commander during that assignment. I know you had him on a little while ago. He encouraged me to go apply to be what's called an executive officer. And it's really like it kind of like an executive assistant to a senior leader. And so I went to go be the executive officer for General C.R. Davis, who was a 2-star at the time. And he was the program executive officer for weapons. And what the program executive officer is think of a very senior program manager over a large portfolio of programs. And so I got to see in that job what it's like to actually make the important decisions, solve the problems necessary to field critical capabilities to the warfighter, and the difference, the impact you could have. And so, as much as I loved flying, wish they would still let me fly, but I love flying and I love doing the test mission. I just saw that there was kind of in my mentality and how I do things, I could make a bigger impact in running running programs and making those critical decisions, really driving towards delivering capability to the warfighter, to the operator.
I was going to say, and you're kind of at the nexus here from integrator operator perspective, right? You get to see what the warfighting requirements are, but also the kind of the future demands and the future capabilities that are needed to help support this executive office. Do I have that right?
So when I was working for him, I saw a lot of that. And I think one of the things maybe we can touch on a little bit later is how with the Secretary of War's new acquisition transformation, how we're doing like the requirements thing a little differently. Obviously, you probably heard about the JSIDS process being dismantled, if you will. But in that role, back working for General Davis, that was my first look at getting to see that, seeing the technology that's being developed, by our teammates in AFRL, seeing the requirements for today, the future requirements that are coming down, and seeing how those come together and capability that we can put in the hands of the operator.
And so for those that are listening, AFRL is an acronym for the Air Force Research Labs, which is one of the subcomponents for Air Force Material Command, if I understand that correctly.
Exactly right. And hopefully we'll spend a little time talking about the collaborative combat aircraft, because it's one of the things I get the privilege to work on right now. There would be no CCA program without the work that the AFRL has done to date. And leading up to it.
So describe what CCA is, because many people may not be tracking exactly what this is. And when you describe it, also describe why it's important. I mean, why does the Air Force need CCA as a capability versus what it has historically done?
We generally, I think the right way I like to focus when I talk about a capability is the why behind the capability first. And the why really is that we need to be able to get out. We need more mass, especially if you start thinking about a high-end conflict. If we ever had to go there, or at least deterrence of a high-end conflict, you need sufficient mass in many domains, but in the air-to-air domain, you need enough capability and capacity out there. Now, one thing that we're able to do with differently on collaborative combat aircraft is we have made them semi-autonomous, so they're unmanned, and we're making them smaller and more affordable so that we can actually build the mass and not have to generate as many pilots to do so, and we can do it at a lower cost point.
Interesting. Well, I mean, and with the unmanned piece, that gives a lot more versatility to the different types of missions you can conduct in an air-to-air type of combat, correct?
It does. It really gives more flexibility to the operational commander to make decisions on what level of risk they want to take. It also does more than that. And one thing I probably should have talked about with the collaborative combat aircraft is the first word is collaborative. Right? Which means that they are designed to work with our manned fighters. We're able to provide additional capability to those pilots in so in the F-22 and the F-35 that are out there. We provide them more capability by providing them collaborative combat aircraft that they can quarterback. So that gives them more capability. It also provides more protection to those pilots as well. Because if we get down to a situation where a decision has to be made between losing a semi-autonomous collaborative combat aircraft or one of our piloted fifth gen, it's an obvious answer. Absolutely. And so we give that choice to the operational commander to make.
Yeah, you can't really put a price on a person's life, right?
Yes.
So with these unmanned capabilities that are working in concert with the manned capabilities, now if there's a split decision on which asset to take out, it's a no-brainer, right?
Yep.
So now with describe when you say CCA, I mean, is that a whole fleet of capabilities? Is that one capability? How is that being structured right now?
Yeah, and maybe I'll take a step back. One of the things that we're doing is looking more at a system of system fight. So traditionally we've spent time building the very best of an aircraft to do this one thing, and all by itself, right? And so we sometimes call that like the organic kill chain. You need a closed organic kill chain, but we want to be able to bring in many more ways of executing the mission, and you could do that by fusing together multiple platforms into a whole system that can work together. They can one can sense, one can shoot. They can talk together. They can communicate, pass information along. Collaborative combat aircraft there's a program around it. We'll call that like the first increment, and we're doing a lot of work there, which we can talk more about. But it's really a concept of a series of different platforms that provide whatever capability we need. And so the first increment that we were fielding is really focused on providing an air-to-air capability. So they will carry weapons. But a second increment, which we're already working on, and we're nailing down what it's going to be, could also be a weapons truck, or it could be, an air-to-air platform, or it could bring like sensors or electronic warfare capability, whatever the total system needs to be most effective.
Okay.
So we can maybe talking about the increment one is a good one, because that one's in the media quite a bit.
Yeah. What is increment one? What does that mean?
Yeah. The concept there is, how do we deliver affordable mass that's capable, that can provide semi-autonomous capabilities. And we're doing that. There's really two key areas to it. One of them is an aircraft. And we're currently working with General Atomics and Anduril, who've been phenomenal partners in fielding our initial test assets and flying them now. And then there's a big part of it, which is the mission autonomy. So think the brains of the collaborative combat aircraft. And by using some of the principles that the Secretary of War talked about, going to different people, General Atomics and Anduril, for the aircraft than we are for the mission autonomy. And we do that through some government reference architectures that we could talk more about. But bringing those two things, the mission autonomy and the air vehicles, that gets us to combat capable, semi-autonomous air-to-air vehicle, air-to-air fighters that we can pair together, team together with manned aircraft to get maximum effect.
And that maximum effect piece is an interesting way to close that out, because yesterday I was having a discussion with Anduril about how they're incorporating a lot of artificial intelligence into, some of the ways that they're creating a foundation as a company, and leveraging those capabilities for this next generation type of, warfighting platform is something that is largely talked about, but rarely implemented. I mean, with the government acquisition timelines, a lot of the really neat science and technology that is available commercially takes years to get into, our systems, right? I mean, the acquisition timelines take 10 years at its best, given the legacy way of doing things. But that leads into a comment you made earlier, right? We're moving faster within the Department of War. Secretary Hegseth has came out and said we need to be a lot more commercial in the way we're thinking, shortening these timelines. So how are you seeing, some of these initial kind of thought pieces coming in and helping out with such a massive rollout that the Air Force is doing?
A few pieces to take apart there. One is, when we think about AI and autonomy, there's way more applications than just the autonomy that runs an air vehicle that's semi-autonomous, and we could touch on that. But maybe more impactful for the overall enterprise and the Air Force as a whole, what the Secretary has driven us to make fielding, the speed to field capability so important. And we CCA is really emblematic of what the Secretary was talking about. We actually took in less than 2 years from contract award until to go design, build, and go fly both the GA and Anduril aircraft. Now that's That's like less than half of the benchmark for any unmanned platform before that.
That's lightning speed.
Yep.
That is extremely fast. Having worked with internal government contracting offices and the such, I mean, 2 years is usually about the amount of time to get a solicitation out, get responses back, and then provide an award, not even get stuff fielded. I mean, that's an incredible speed.
Yes, and it is a team effort to go do that, right? You couldn't do that without industry, right? We also couldn't do that without executing many of the principles. We call them next gen acquisition, which is just a completely rethinking of how you do acquisition. Without using those principles and working with our Air Combat Command teammates who own the requirements and our industry teammates, we wouldn't be able to be there. Another thing to note on it is that it's not really just about fielding that initial capability. We also have to think about the next step and the next capability. Because as you mentioned, capabilities are developed in industry, or the Air Force Research Lab will develop capabilities, maybe a new, better autonomy or a better electronic warfare algorithm or a better radar. And you want to be able to integrate those quickly. What we have done is following, if you've ever heard of MOSA, so modular open system approach.
But what is that?
It's really it's a guiding principle for developing technology in a modular way, whether it's software, whether it's hardware, that allows you to change out individual pieces of it so very quickly without having to like replace the whole thing. And in many cases, when we go in our fielded platforms and you want to replace one thing, you have to replace the whole system. So think an example might be if you wanted to replace the one hardware capability in a box that's in a fielded platform, you generally have to replace that whole box and all the connections. Whereas a MOSA approach would design the box to have cards that can be easily removed and replaced.
So it's almost like a form, fit, and function, kind of like a set of Legos. I mean, you have a base here, and you just are interchanging the pieces as needed. So your mean time between repairs is drastically reduced because you're not sending it back to the prime. So you'll redesign the entire thing, saves the government money, so saves the government time. And now that fielded capability is spending less time on the tarmac than it would have historically. Do I have that right?
That is right. And hardware, we're definitely ways to do that. We've done that, and what we're implementing, it's a long acronym. It's AMSGRA, but it's Agile Mission Suite Government Reference Architecture. We don't need to use that again, but essentially, it is a government reference architecture that, at its core, allows us to take anybody's compliant software and put it on anybody's compliant hardware. And so I liken this to an iPhone model or an Android model. It's kind of like your iOS, right? It's not the thing that people think about when they think of the iPhone or the Android. You really think about your apps, right? And so in an iPhone model, and you compare that to we'll compare that to an F-47, for instance. Your iPhone has or a CCA has a bunch of sensors on it, right? It's got a camera, it's got microphones, it's even got data links. We call them like your Bluetooth and Wi-Fi connection. It's got a display, it's got interaction. F-47 or CCA is the same way. You've got sensors on it. They might be like an IR sensor or like an infrared sensor, or it might be like a radar. You also have communications you have to do. And so in the same way, it's somewhat similar in that case. The iOS ties all those things together and sets the software standards so that anybody can bring an application to bear that meets their standards that can then control things on that iPhone. It can activate your camera to take a picture and put on Instagram, if you will. It's the same way for the AMSGRA. It's like your iOS that allows me to bring anybody's software that's compliant onto the aircraft to be able to control the different sensors.
So man, my mind is going crazy here thinking about all the applications, right? If you have this software domain that is connected to all of these different systems, now there's potential for things like executing at the edge, or things like rapid deployment of upgraded software for mission requirements. I mean, it seems like this creates yet another large step in not only the department's capability, but a protective mechanism for our national security. So with all of these different kind of pieces happening in tandem, your role right now is overseeing the next generation air dominance, correct? Why don't you describe what that is? We talked a lot about some of the unmanned pieces, but what is that overarching piece?
Yeah, it's really a family of systems that includes the manned F-47 program, the unmanned collaborative combat aircraft, those architectures that I talked about, and there's more than just the AMSG array. There's also an autonomy one that's really interesting I could talk about, and then some of the critical mission systems. So when I talked about those sensors, so developing those mission systems. And obviously, it's complemented by advanced weapons and things like that. But that's really what the next generation air dominance family of systems is.
Within that, how does this? And this is more for me being a novice. You have the next generation air dominance. Is that a subcomponent to materials command, or how does that kind of fit into the large Air Force ecosystem?
Yeah, so the organization that I run is actually called the Agile Development Office. And so the Agile Development Office is responsible for the next generation air dominance family of systems. So from organizationally, the Agile Development Office falls under Air Force Materiel Command. It actually falls within the Fighters and Advanced Aircraft Directorate, which is under the Air Force Lifecycle Management Center, which then reports to Air Force Materiel Command. Moving away from the organizational, where it really fits in is I think about it fitting into capability to the operator, and that is we already have a phenomenal fielded fleet, F-22, F-35, F-15EXs, F-16 that are phenomenal air superiority and have a tremendous edge over our potential adversaries today. But our potential adversaries are not staying still. They're moving, and in many cases, they're moving faster than they've ever moved. And so the next generation air dominance family system is really about fielding that next generation of capability that will make sure that our operators, our pilots have continue to have the edge that they have today.
Well, and this is one of the challenges, with a role like yours, because you have your traditional warfare that you will, be tracking like threats that are happening over in, Taiwan with, potential Chinese conflicts. You have some of the stuff that's happening over in Israel, but you have some of the things that are brand new conflicts that are coming up. Venezuela, for example, is now on the radar as being something that is of major interest to the United States. So the adaptability for, all of these different types of environments that are known and then sometimes that are not known, having this agile piece is unique, and it seems like it's kind of embedded in the overall thought process of why we need these tandems of manned and unmanned capabilities. Correct?
I agree. The most agile thing that the Air Force has and has always had is the ingenuity of our airmen, and they continually, time after time, find unique ways to take what they're given as capability and make it work for whatever pops up. What I want to do is I want to give them much more flexibility so that their capability that they have that they're making work today, I can tomorrow or even later today give them new capability that better suits whatever they're being asked to do by the nation.
So kind of leading in with the traditional irregular warfare piece. We talked about the Air Force Research Labs. We talked about things like AI. We've talked about a number of these different technological enhancements that are really foundational. Where do you see kind of one of the biggest hurdles right now from a technology integration perspective, that if we are able to overcome this, it's going to, further enhance our superiority?
A few things out there. One of the big ones for me is, and it's talked about a lot, so I'll try and put it in a little different context, is artificial intelligence and machine learning. There is a tremendous amount of work that is happening in that space. However, what we have not done is looked at all the best places to use it. We many times talk about it as at the bleeding edge, that's where we want to apply it. And sometimes it's much simpler than that, right? It is the ability for the test community to real time assess test data and move on to the next data point, as opposed to finishing the flight, downloading the data, doing data analysis, and then being ready a week later to go fly the next thing. That's just another way to accelerate capability delivery, is accelerating on the test side. I'm very close to that because of collaborative combat aircraft. The interesting thing that we found when we started really doing market research around what autonomy was available and how the market was, is we determined that there's tremendous autonomy by ground vehicle companies and by air vehicle. They've both done tremendous work. What the ground, so like car industry has, is they have tons of reps and sets on that autonomy, right? And I'm not sure what kind of car you drive, but if you drive a Tesla or another autonomous driving vehicle, you are learning and feeding that back to Tesla. And so they're getting lots of reps and sets on it. What we need to do is put capability out there so that we can get reps and sets on airborne autonomy. And then that will enable us to then bring in greater and greater levels of autonomy. So you take the DARPA Air program, which is really focused on bringing AI to the autonomy at a high level. We need to have a proving ground where they can get reps and sets on that type of autonomy. And so you may have heard of the F-16 Venom program down at Eglin, where that's one way that we're going to get reps and sets on autonomy. Obviously, now that we have flying CCA, really close to starting to get lots of reps and sets on airborne autonomy that will just take it to that next level, prove out what we've got right and what we need to make tweaks on.
Do you believe that we're far away from getting a lot of the similar kind of benefits that Tesla, a great example, has with their autonomous driving capabilities? Do you think that our platforms are very far away? Do you think we can leverage lessons learned from industries like the auto industry? What's your perspective on that?
Well, on the lessons learned piece, we have learned many lessons. One is about having a very good, faster than real time simulation capability. And so that's one thing that we've been working with industry to build up, is to be able to get, some amount of reps and sets in a software, in a virtual environment. Relative to our aircraft, we're really close to going flying our mission autonomy on our collaborative combat aircraft that are flying right now. And we will just continue to do that, get reps and sets. That takes both having autonomy companies that are working hard, which we have. It also takes us having more aircraft to go so we can fly more often. And we are moving out really quickly on those. You probably heard General Atomics has already flown their second aircraft. I expect Anduril to fly their second aircraft pretty soon too. And aircraft 3, 4, 5, 6, 7 are all in various stages of being built. And we will get them out there, get them in the hands of the experimental operations unit, which I can talk more about, so that they can get those reps and sets on autonomy and how to operate those collaborative combat aircraft with our manned platforms in a real world environment.
And you're just creating a larger data set, right? With all of these different systems that are out there now, using the term that you're using, your reps and sets, right? You're no longer beholden to one single platform. Now you have 2, 4, and I mean, hopefully the number, gets to a point where it's just refining the model, not building the model, and that will happen over a period of time. One of the things that did come up as I was, kind of getting ready for our discussion, was kind of a basic question: how does it differ from a drone to the CCA stuff? Why is there a difference there, and why would one care?
We have the traditional RPAs, remotely piloted aircraft, are just that, remotely piloted, and so they are there are pilots on the stick or keyboard, whatever the case is, real time flying those aircraft, and they actually have a pretty large crew of people that it takes to generate and operate those aircraft. We are flipping the script with CCA. And so whereas it's many people to one aircraft, we are driving it to have the autonomy to allow many aircraft to one person. And that person could be, the way we are envisioning it right now would be we call them a quarterback, but they'd be a pilot and a manned fighter.
Okay.
And they would be able to, if you will, call plays that the CCA would go execute, and they would also be the person who makes any lethal decisions.
Okay.
So that's one of the key things about the CCA that is really critical, is that we call them semi-autonomous specifically because no lethal decisions are made without a human in the loop making that decision in accordance with DoD instructions and ethical use of warfare.
So to kind of put this the way that my brain thinks is, you have a Predator drone.
Yep.
That person is on the joystick somewhere at a location, driving that around, setting what the parameters are to either execute a mission, take out a specific asset, whatever it may be. In the CCA domain, now you have what you said quarterback, someone that is piloting a system, but he's the play caller. Mm-hmm. He's the one that's saying, okay, football analogy, you're going to run a post here. It goes and runs the post, and he goes, and that's what the expected piece is, but in a tactical application. Correct?
Exactly. Yep.
Interesting. And I assume that all of this network of capabilities happen in tandem. It's not superseding what the drones do. There's mission applications for both.
Oh, 100%. Yeah, the Air Force has been very clear that collaborative combat aircraft are additive to the fleet. So they are being added to our fleet to augment what our manned fighters can do. And our drones or remotely piloted aircraft are usually in more of a intelligence, surveillance, reconnaissance role. The collaborative combat aircraft different than that will be in a fighter aircraft role.
And kind of following this thread, now with not having someone sitting in these unmanned aircraft, substantially reduces the weight of the overall system, which means that there's a lot more flexibility in deployment. So in my head, I'm thinking about some of the using the example of the Venezuela stuff, where there's drones that are sitting on carriers and stuff, and they can pack a lot more, be able to take shorter takeoffs, landings, and the such. I'm assuming there's a lot of lessons learned, once again, that can be applied in this domain as well. So I'm seeing just a lot of flexibility as my brain is kind of thinking and conjuring up, how, if I was in charge of the Air Force, I would be flying these different types of things.
I agree that they provide tremendous flexibility. And when you think about operating in different areas, you're going to have different levels of buildup of bases. And so the CCA are designed in mind with making it a very small logistics footprint too. So you can, not only do you have a small, that you don't have pilots and you can make them smaller, but the logistics maintainer footprint is much smaller than with some of our traditional aircraft.
So the next piece I have, we talked about, what you see the technology enhancement challenges may be, where do you see the real kind of shot of adrenaline coming in from a technology perspective? Where are you seeing like the biggest push? Is it still in the AI space, even though that's the big gap? Or is there another technology enhancement that has really, taken strides in some of the successes early on?
I have seen some of the biggest strides less in the technology, because the technology is always coming. It's more in setting up systems or ecosystems so that we can ingest that technology at a faster pace. And that's why when I talk about the government reference architectures, which make it so easy to bring new software capability to bear, or building physically in a modular way so that I can bring new physical capability to bear, and I can make those mods, bring that capability much quicker. That's where I see the real injection of, I think adrenaline is maybe what you said, but like that allows us to go faster. It's not just, can we go fly prototypes at a rate that's never been seen before, but once we field those things at a rate that's never been seen before, can we continue to give them, upgrade their capability, especially if it's software, faster than we've ever done before.
Yeah, that modular piece is extremely exciting because a lot of historic platforms just stay grounded for such a long period of time. Examples like the B-52, it's a legacy system out there. It will have a long service life. It still has a lot of utility, but when a problem comes up, they did not think about the modular portion of this. It's take out subsystem, either reverse engineer it, find a way to repair it, but that guy is grounded for a long time. Where this modular piece, you may have spares on hand and swap them out quickly. You're back in the fight. So I kind of have two more questions for you here. What is the future of the Air Force, right? You're kind of on the bleeding edge right now with a future set of capabilities, but where do you see the Air Force going after this?
Yeah, there's a few key lines of effort that I see the Air Force moving out on. One is that we are moving away from individual platforms that work all by themselves in a silo. We are moving towards that system of systems. And the work being done by C3BM office, the command control, battle management office, to really connect together these different systems is what's going to take us in the future. That provides so many different avenues to take advantage of capability over here and over here together to really expand what we can do. The second one is, I think we will continue to proliferate autonomy. We're going to show it with collaborative combat aircraft, and we are going to, with increment 1, we're going to have increment 2. There may be follow-on increments after that. There may be autonomous vehicles that fill other roles. Maybe they could be a mobility platform, a tanker, or ISR, the intelligence, surveillance, reconnaissance, in one of those roles. So we're going to see that more and more, which is going to drive more human machine teaming. And the human machine teaming will become much more prevalent because we can reduce risks to our pilots' lives. We can provide them more capability, and generally we can field things quicker with providing more options to our operational commanders. And then maybe the third one that you'll see is what I've talked about a little bit, which is how we're fielding capability differently. The Secretary of War talked a lot about the acquisition transformation. And I think you're going to see the Air Force was already moving out in that in several ways. And you're going to see us move out with even more vigor. The path that the Secretary has laid out is exactly what we need to go down to deliver capability with speed and being able to quickly upgrade it.
Yeah, I was talking with General Panaro about this, and he was saying, under the administration right now, it's a ready, fire, aim kind of approach where speed is one of the biggest pieces that is being implemented today. So what you're describing here with rapid acquisition, you see things like the SPEED Act using speed as an example, Speed Act in helping to reduce this. You see Secretary Hegseth with transition from FAR-based types of contracts to leveraging a lot more OTAs. And I believe that memo came out last week. So there is not only an awareness that has been picked up across the entire Department of War, but it looks like a lot of the foundational pieces are starting to become implemented, so that way people like yourselves can move at speeds that, you know, the Air Force is intended to, and not get bogged down by a lot of unnecessary government paperwork. So that's pretty exciting. So the last question I'll have for you is you know, you've had a pretty interesting and awesome career, right? I mean, we talked about the stuff that you did with your training with the Navy and in pilot school, being able to oversee, you know, a variety of different programs at the executive office level. So where do you see your future going? You're currently, you know, a colonel in the Air Force. So that is I mean, that's a pretty, you know, high bar already. But what do you think your next set of steps are?
Yeah. So I'm super fortunate that I've gotten to do the things that I have. If they let me do this job I'm doing right now for the next 10 years, I would be super happy. Just the ability to lead acquisition warfighters and put capability in the hands of operators is so important. There's a lot going on. We'll see how what the Air Force has in store for me. But I'm here and happy to serve, and again, love leading acquisition warfighters and love delivering capability. So hopefully I get to keep doing some of that.
So Colonel Helfrich, it's Tim, it's a pleasure having you on here. And I look forward to not only seeing how you continue to protect national security, our great nation, but your leadership and influence as it continues to, you know, make strides in the programs you're operating and the future that you have. So thanks a bunch for joining us here on Microjourneys.
Thank you so much for having me. Really enjoyed it.